Okay, guys, we now move to lesson number 2. Lesson number 1. Yes, Duran. Hi. Lesson number 1, we tried to quickly, we did quite a number of things on the grade 10. We quickly tried to fine-tune grade 10. So, guys, we are moving to grade 11 quickly now. Today is our mostly it's grade 11 work. But just a quick revision. Yesterday we said we have scalar and vector. You must know this definition and examples throughout your physics here. All right, how do we represent vectors? We use a tail and the head. The length of the tail will always give you the magnitude, while the head will give you the direction. All right. The direction of your vector quantity. Okay, we talked about resultant. This is the third definition you should know. First one is scalar. Second one is vector. This is the third one. A vector sum of 2 or more vectors. That's called a resultant vector. Collinear vectors. Vectors in the straight line. Okay. In the course of the year, we're going to release a material that will help you deal with your definitions. Okay, we said always give direction, please. Before you start calculating, write down the direction of your vector. We did tail to head, tail to tail. All right. We did some questions. Now, grade 11 part. We said you're going to have 2 dimensions, hence the topic vector in 2 dimensions. When we say 2 dimensions, we talk about the y and the x. That's why it's 2. Y and x. 2 dimensions, 2 axes. Number 1, combine all linear vectors. That is, all the y's combine and have 1. All the x vectors, combine them and have 1. And since it's vertical and horizontal, it will always be perpendicular. That's the key word. It will be perpendicular. And once it's perpendicular, what do we bring in? The theorem of Pythagoras. Okay, FR squared equals to F1 squared plus F2 squared. Lovely. So we did a few questions. Now I'm going to jump into today's work, and we did the angle. All right, we did the angle stuff. Okay, like I said, as we do more questions, you begin to see clarity on how to deal with that angle. Now, let's look at this. Components. So we're starting today. Components of an inclined vector. And when I mean an inclined vector, I'm actually meaning a resultant vector. A resultant vector. When I say components, I am simply saying what makes up a resultant vector. Remember, a resultant vector is the sum of 2 or more vectors. Don't forget, resultant is made up of 2. So we are saying every time you have a resultant vector, this should be changed into, and I want to use an arrow, this should be changed into a horizontal and a vertical component. So we are quickly going to learn how to do components this morning. Components. For horizontal, we will be using X, and for vertical, we will be using Y. While this one is your F resultant. No, let me bring this to your attention. We can also use the word net. The word net and the word resultant means the same. Resultant and net means the same. So when we look at a resultant force, we will have to break it down into so we are reversing what we did yesterday, guys. Okay. To find components, to find the components, we create a right angle triangle. Okay. We create a right angle triangle and use our trig ratios. I'm going to give you a note quickly. The side opposite the angle we use sine theta. If you can remember that, it will simplify your work. The side opposite the angle, we use sine theta, and the other component becomes cos theta. I'll explain, don't worry. But if you can just quickly remember that, because that will also help you in grade 12. If you can put that at the back of your mind, it will assist us a lot to make things fast. All right, please, I'm waiting for you to quickly write, and let's go into work. Physics is not a lot of notes, but I just give you this so that when you are revising, it's easier for you to remember. The faintest ink is brighter than the sharpest memory. We learn by writing things down. All right, I'm ready to move to the next page. Can I? Thumbs up, thumbs up. Can I move to the next page? Amanda, your hand is up. Is that a yes? Spamandla, what's the story?
That was a yes.
Okay, all right. Spamandla, give me a thumbs down. Spamandla, can we move now? Gavin Mokwena, your hand is up. If you want to say yes, just use your thumbs up. Okay, Spamandla, we're good. All right, Gavin, your hand is up. All right, okay, there are two Spamandlas, I see. Gavin, your hand is up. Do you have a question? Otherwise, please put that hand down and note it, okay? So we only raise our hand if you have a question. If you want to tell me yes, just give me a thumbs up. All right. Example, quickly. Let's look at this. Example. We're going to create that. You know this north, south, east, and west. Okay, let's create a force. Look at that force. And let's make this angle 30 degrees. And this force is 30 newtons. Okay. Now, this examiner has given us a resultant force. Guys, please, I want you to listen to the first example. This examiner has given us a resultant force of, so our F resultant is 30 newtons, 30 degrees. Remember, starting from the positive and going anti-clockwise. This is the example. How then do we find, here's the question, find the vertical and horizontal component. Find the vertical and horizontal components. Please, I'd like you to listen to me carefully on how to determine where my vertical and horizontal component will be. Look at this force. This force is in between two directions, right? What do I mean? This force is between the north and the east. Let me know if that makes sense. When I say it's between the north and the east, talk to me. It's in your first quadrant with maths. Are we okay? That force lies, so you need to first check the position. It lies between the north and the east. Or, look, there are so many languages. You can say it's between the north and east, or you can say it's between up and right, north, east, upright. It therefore means, once you get that set of direction, It means that when you then draw your force, my beautiful learners, watch what I'm going to do now. This will now determine whether you get it right. I have this. It means when I draw my force, one should be going up and the other one should be going right. Because the force originally is between up and right. It's between north and east. So, here is my component. I'm going to use yellow. Up and east. So, let's draw the east. East and then up. Does that make sense? The aim is to form what you call a right angle what? Triangle. Let me know if that makes sense, guys. Please let me know. This is now the right. You can see right, which is the east. And this is what? Up. You are forming a right angle triangle. Beautiful. And once you form a right angle triangle, you now have a 90 degrees. That's the main aim. And this is our angle, 30 degrees. This is 30 newtons. I am therefore going to call this Fy, and I'm going to call this Fx. Y vertical, X horizontal. Don't forget that. Y vertical, X horizontal. My beautiful learners, I want to ask you a question. Which side is opposite the 30 degrees? Is it the Y or the X? Look at the 30 degrees. Which side is opposite? All right, I'm beginning to get my answers. Please make sure you are not lost. If you are not sure, let me know you are not sure. Awesome. Awesome. Great. So if we were to label trigonometric grade 10, this would be what? Opposite. The side facing our angle 90 is known as the hypotenuse. And then we have what? Adjacent. Now let's do a bit of trig. What is sine theta? Sine theta is opposite over what? Hypotenuse. Okay, let's substitute. Sine 30 degrees. What is my opposite? Fy. What is my hypotenuse? 30. Let's cross multiply. Fy is what? Okay, this one is just 30. Cross multiply. 30 sine 30 degrees. I'll take you back to the statement that I said earlier on. Look at this statement. So a learner who knows this statement will not be wasting time. The side opposite the angle, we use what? Sine. The side opposite the angle, we use what? Sine. The side opposite the angle, we use what? Sine. Are we okay there? Everybody good? All right. So I could have just simply looked at this and know that, oh, it is the side that is opposite. All I'm going to say is Fy is F resultant sine the angle. The side opposite, we use sine. You just bring it. F resultant sine of the angle. Let me put it there. We use sine. You can just write this there. Once you know that, life becomes very easy. All right? For the opposite side, opposite component, just put this in a, it will be F resultant sine of the angle. F resultant sine of the angle. Are we okay there? Beautiful. So do you notice we have an answer? Do you want to get me an answer quickly? Calculators. Confirm my answer. I know sine 30 should be half. 15 Newton. Confirm. Is that what we have? Is that what we have? Thank you, Spamandla. Beautiful. Now, the other one, check. Cos theta adjacent over hypotenuse. Cos 30 is what? Fx over 30. Cross multiply. Fx is 30 cos 30. All right. Give me an answer there. Give me an answer. I want to show you something quickly, then I'll give you one question. 30 cos 30. Let's quickly walk through that. 30 cos 30. What do we have? 15 root 3, which is 25,98. Okay, guys, are you okay with what we've done so far? Let me know. I want us to prove this. I want us to prove this. I want us to, and we are proving it's going to be a way of revision. Let me know quickly. All right, make sure there's no thumbs down. Why can't we use Pythagoras? For you to use Pythagoras, you must have what? At least two sides, remember? After getting your 15 on one side, you now have 30 and 15. Then you can use Pythagoras to get the other one. But that's a long journey. Yes, that's what I'm saying, Kian. After working Fy, you can, but that's so, you have to square, subtract, that's long. Here you just pop in quickly, you're done. Okay, what happened? There was an error. Let me see. Okay, guys, I don't know, something happened to my screen. I won't be able to see your messages just 1 second. I'll tell you when I'm back online. One moment, I'm still here, just my other system, my monitor went off, so I want to make sure it's back on, and then we'll deal with your questions and practice quickly. Let's see, somebody just give me a thumbs up if you can see my screen. I want to see something. Okay, all right, so we're back. Thank you. Kian, I hope what I said makes sense. You can use Pythagoras once you have one other side. Let's quickly confirm something here, guys. We have two forces. This was what we're given. I want us to go back and revise what we did yesterday. Okay, so we have two forces. That and this. This is 15 newtons, and this is 25,98. I think that was what we got. All right, good. Check this. We have this. How do we find our resultant? Do you remember this yesterday? I'm trying to now use the same answers. What do we do? First thing is to complete that. The head. Now what do we have? We have our resultant. Do you remember that, guys? F what? Resultant. And now this is 15. We would have said F resultant squared equals to what? 15 squared plus 25,98 squared. And then we get a calculator. This was what we did yesterday, right? 15 squared plus 25,98 squared. And then we look for the square root of that answer. Check. 29,999. And that would give me 30. Do you see that we've gone back? So what we did today was to unravel what we did yesterday. And this is my angle theta. How would I get theta? Tan theta is opposite. This side is the opposite, right? 15 over adjacent, 25,98. Theta, therefore, will be, let's find out what our angle would be. All right, so we'd say 15 divided by 25,98, which is that. And we'll say shift 10 answer. Check 30,00, 30 degrees. Please, is it making sense now? Look at what we did yesterday versus what we did today. We've gone forward and we've reversed the whole situation again. So the examiner gave us 30. We split it into vertical and horizontal. So if you are given vertical and horizontal, now you can find your resultant. Can you see we have the exact same answer like we had yesterday? Are we good? Can I give you a question quickly to practice for me? Let's see. I want to give you a question quickly to do for me. Beautiful. Beautiful. So let's find the resultant, or let's find the component of this force. Let's find the component of this force. Let's make it 50 newtons. All right. Find the vertical and horizontal components. Find the vertical and horizontal components. Let's give a time frame of 5 minutes. It will be shorter once we know what we're doing. Find the vertical and horizontal components. Let's make that fast. All right, I see answers. I hope no one struggled. I'm just seeing a bit of, there's a 3-1, there's a 3-6. Okay, let's see quickly. Like I said, our first job will be to identify. And you have identified the position. So if I were to draw this force and complete a triangle, what would I have? Quickly, what would I have? I have that, I have that. Okay, so this, if I complete a triangle, what would my triangle look like? One should be acting down and the other one should be acting to the right, because our force is down and right. So we're looking for the sides. Down and right. And where's my angle? 45. What is my force? 50 newtons. So what do we have? Fy, and what do we have? Fx. Which side is opposite? Fy is opposite, so it's now easy. I can just say 50 sine 45. Actually, your answers should be the same from what I see. Fx automatically becomes what? Cos 45. These answers are the same. And if you put that in a calculator, I want to follow your answer, 35,36. Okay, 35,36 newtons, and Fx, they are the same. All right, because sine 45 and cos 45 are the same. Thank you, guys. I hope it makes sense. All right, I see Tebo giving me a negative there. That's okay. You're telling me that you understand that it's going down. All right, but this time around, I'm just looking for components. Guys, well done. Is there anyone who is lost? Let's quickly see. If you are lost, give me your thumbs down. So we all move together. If you are lost, thumbs down. Okay. All right. Now, let's do something nice now. Finding the resultant of two inclined forces. Finding the resultant of two inclined forces. When I say inclined forces, this is what I mean. Inclined forces are forces at an angle, like we've seen. Forces at an angle. Now, what are the steps? Number one, find the vertical and horizontal component of each inclined force. I want you to write something for me. We always resolve. This is called resolving. So in case you hear the word, we always resolve inclined forces, because we are going to do Newton's laws and we are going to bring this back in. We always resolve inclined forces. So anytime you see a force at an angle, you're going to do what we did. You find the vertical and horizontal, because that's the one we want to work with all the time. We want to work with reason. We want to work with vertical and horizontal forces. We want to work with vertical and horizontal what? Forces. This is why we always resolve. Number two. So you guys know how to find components now, right? So when you see an inclined force, what you do is you find the vertical and horizontal. Now, if there are more than one, all right, two or more, I should have said two or more. If you can just shift that and write two or more inclined forces. two or more inclined forces. So you find the vertical and horizontal component of each inclined force. Number two, find the vertical resultant. Find the vertical resultant. This was what we did yesterday, because now you are going to have more than one vertical force. Find the vertical resultant and the horizontal resultant. And I'll do an example for you quickly. And the horizontal resultant. Number three, find the new F resultant. 3 steps. Basically combining what we did yesterday and this morning. And you would see the importance of that right now. After this, I'm going to be talking about equilibrium forces. So we're moving step by step. Giving you a moment to finish writing. All right. Can I move? Let me see. Can I move? Can I move? Great. Okay, who's still writing there? I saw a thumbs down. That's Spamandla. Okay, let's write very fast. 30 more seconds. All right, Spamandla, we're done now, right? We can now move. We can now move. Thank you. Okay. Find the resultant force. Look at what an examiner will now do for you. Find the resultant force. There are 3 forces here. (25 degrees). Let me change this angle. I want to see your maths. 30 degrees. This force, 20 newtons. This force, 35 newtons. This force, 25 newtons. Let's add one more. Somebody saying, oh my God, what a guan. 16, in fact, let's add one more. 50 newtons. All right, check. How many forces do we have? 5. We have 5. 1, 2, 3, 4, 5 forces. Now, let's quickly, I want to label these forces, guys. I'll call this F1, F2, F3, F4. I want to ask you a question, F5. Which forces are you going to resolve? Please type your answers. Which forces are you going to resolve? Because I need this. Which forces are you going to resolve? All right, I have F2, 5, and 4. F2, okay. Leiden, Landen van Krienen. I hope I'm pronouncing well. Do you want to unmute yourself quickly? I want us to talk while I'm waiting for other answers. Okay. Penuela, either Lady or Penuela. Is there anyone who wants to talk to me, both of you? Or Noran? Or Tobo? Because I see you guys have the same answer, 2, 4, 5. Do you want to talk to me? I need someone to talk to me quickly. Guys, when we talk together, we are learning and helping the class. I want us to have a forth and back conversation.
Good morning, sir.
Hi, Noella. Good morning. Penuela, right?
Yes, sir.
Okay, how are you?
Good morning. I'm fine, sir.
All right, Lady. Okay, let's keep the mics on. I love that. So I'm talking to both Penuela and Lady. Good morning, guys. All right, let me start from Lady. Penuela, keep your mic on. Okay, Lady, why are you going to resolve 2, 4, and 5?
Sir, because they are just going, F2 is just going up and there's no angle involved there, sir.
Okay. All right. Hold on the mic there. Penuela, talk to me.
So the reason why we are solving for F2, F4, and F5 is because F2 is the F, for example, Fy, and also F5 is a Y, and F4 is X, and F1 and F3 are angles. They are the resultant forces.
Okay. All right. Okay. You can mute your mics now. Or Lady, do you have something else to say?
No, sir, I'm fine.
All right, guys. Let's quickly go back to what I wrote here. We have 5 forces. We are given 5 forces here. Everybody, please listen carefully. F1, 2, 3, 4, 5. And we are looking for the resultant of all of these 5 forces, because resultant force is a single vector that has the same effect of 2 or more. So we have 5, but we want one vector. One vector. Is that fine with everybody? Please listen carefully. Now, I said something here, the one in bracket. We always resolve inclined forces. That's the one you resolve. Which forces are inclined? The word inclined means it has an angle. Which ones have an angle? It is 1, 3, and 5. Now, 1, 3, no, just 1 and 3, yes. Only 1 and 3 have angles. These are the ones you are going to resolve. My dear learners, when a force has an angle, it is called an inclined force. And then, those are the ones we are going to resolve. F2, F4, and F5, you don't need to resolve them. Why? They are already vertical and horizontal. So you don't resolve them. Are you with me, guys? You resolve F1 and F3. Are we okay there? We resolve what? F1 and F3. 2, 4, and 5 are already vertical. They're already on the Y and the X axis. So for now, we won't touch them. All right. Thank you very much. I'm glad we are all on the same page. Those of you that says 2, 4, and 5, that's where you missed it. Those ones are not angular. They are vertical and horizontal. So the ones we are going to resolve, like I said, we resolve. And let's look at the languages. We resolve inclined forces. All right, let's see quickly. We're going to take it step by step, everybody. Let's start with F1. So I'm going to need you to practice with me. You are going to do much of the work. Let's start with F1, my beautiful learners. F1. F1 is 25 newtons, right? 25 newtons. So we are dealing with F1 now. and this angle is 30. Please, I want you to find F1x for me and F1y. Everybody, let's use this again to check on how we resolve. This should take you just 45 seconds now. F1x and F1y. Come on, guys, I need answers. I need answers. Why are you giving me thumbs down? What's wrong? F1. We did this a while ago, so it shouldn't be a problem. If you notice, F1 is pointing where? North, up and left. Up and left. Up and left. So that's what you just simply do. Up and left. So if I were to do that, check. I know it's up and left. Up. Is that fine? And left. If you get that right, then we're done. This angle is 30. This is 25 newtons. The one up, vertical, Fy, Fx. That's all you need to do. Did that make sense now? That's all you need to do. It's up and left. All right. I'll do this in two ways for you. Up and left. So the one opposite, what do we use? Sine. Remember. Which one is opposite the 30? Fx. So what is Fx? 25 sine 30. Automatically this one becomes 25 cos 30 degrees. We're done there. Please, did that make sense, everybody? Is there anyone who is confused? Let me know. Let me know quickly. Is there anyone who is confused here? I want to show you something here quickly. Guys, if this angle is 30 degrees, can you tell me the value of that angle? Let's do a bit of maths now. If that angle is 30, what is the value of that small angle? The other angle? All right, great. You guys are super. You guys are super. Let's write these answers. Let me quickly get, while you're giving me that 60, and if you are lost, please type a question for me, or you talk to me. 25 sine 30 would give me 12,5. Beautiful. And 25 cos 30. 25 cos 30 would give me 21,65. Okay. All right. Thank you, guys. That's 60 degrees. Now, please listen carefully. Don't get confused. Which means an examiner can give you this as this. Watch what I'm going to do here. It's the same force. This is still 25. And this angle becomes what? 60 degrees. Does that make sense? We're still doing practically the same story. It's just maths. Now, if I were to draw my component, what would it look like? I have that. It is pointing up and left. So to complete that triangle, we're going to have left and up. What will this be? That is now what? 60 Fy Fx. What is my Fy? F1y. Now check this. Please don't confuse the top with the bottom. This is 25 newtons, right? Fy now is the opposite one. What would it be? I just want to show you. 25, opposite is sine. Sine 60. F1x becomes 25 cos 60. Let's check the calculators and see. What is F1y? 25 sine 60. 21,65. And what is F2? 25 cos 60, and that gives me 12,5. Do you notice my answers are the same? Check. F1y is the same. F1x is the same. So the angle plays a big role. And we're just using maths. Because it's a 90 degrees, we're saying if that one is 30, the other one should be 60. Please let me know as we move on together, are we okay with F1x and F1y? Please let me know. No one is lost. Even with the way I played around the angles, no one is lost. You will understand more when you do tricks this year. When you do tricks this year, you'll understand why sine 30 is the same as cos 60. All right, no questions. Great. Yay! So we are done with F1. Why are we resolving F1? It's an inclined force. Ladin, Nuran, Pinuela, we okay? So which force are we going to resolve next? Remember, we don't resolve the vertical and horizontal ones. We just leave them for now. Which one are we resolving now? Somebody. Which one are we resolving? We resolve inclined forces. Great. Now we are done with F1. Let's go for F3. You would see where this is going to take us by the end of the lesson today. Now, let's go for F3. You guys are so sweet. F3. Okay. So I am going for F3 now. We are resolving inclined forces. F3. F3. Where's F3? All right. F3 is on the other side. $20 newtons, and this is 25. Do you want to do this for me quickly, just to make sure everybody's on board? If we resolve this, it's pointing up and right. So right, always form a right. I'm going to tell you the meaning of this angle, triangle, once we get this right. 20 newtons. This is 25. Remember, the vertical one is always on the y. And Fx. Now, let me just do that now. Which one is opposite? F1, F, this is F what? 3. F3. So what do we have? F3y would be what? 20 is the one opposite. Sine 25. F3x will be 20 cos 25. I hope everybody is now on board with that. I don't want to waste time. There's a lot to be done. Next class, we must jump into Newton's laws immediately. 20 sine 25. This is 8,45. Please use your calculators as well to make sure that my answers are, we are on the same page with the answers. 8,45 newtons. And what do we have here? 20 cos 25. And this has given me 18,13 Guys, I'm rounding off now. You should know how to round off from grades 8, 9, 10. 18,13. 2 decimal places. Everybody okay? Everybody okay? All right. So we are resolving inclined forces. Now, my beautiful learners, thank you so much. Let's now go to the next step. We now combine all the forces now. We combine all the forces. It's quite some steps. We combine all the forces. Ta 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 ta. What do I mean by what did I do? Wait, what happened just now? Sorry, I think I missed a note. This is F3. Oh my God, I cleaned my F1. Blah, 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 blah. Sorry guys, just give me a moment. Okay, now, give me a moment quickly. Just give me a moment. I made a mistake on the board. I did something wrong. 1 second. 1 second, I'll be back now. I'll be back now with you. I want to just get my notes right. I made a silly mistake with something. Oosh. 1 minute, 1 minute. I just want to get my F1 notes back. I'll be right there. Almost. Yep. Okay. Because I deleted, I don't know what happened. F1. And then this part should be my F3. All right, great. So I have my F1. I have my F3. Now we said we are going to combine. Now, what do I mean by combining? Remember the question, we are looking for the resultant force. And our aim is to first change all the vertical, all the inclined. We have now changed them into vertical. My beautiful learners, this is what we now have. Please don't get confused. Watch this. I'll take it slowly. I am going to first draw the inclined forces. All right? It's okay, Denzel. No, I'm going to draw the horizontal and vertical. Which one is horizontal? We've got a 50 newtons there, right? F2. 50 newtons. Next, we have this, which is what? 35 newtons. We've got a 60 newtons. All right. This one, we did not resolve them. Why didn't we resolve? Because they are already vertical and horizontal. Then, we took our F1 and broke it down into vertical and horizontal. Let's go check. Our F1 will now become, remember what we said, it's no longer angular. We have changed it into vertical and horizontal. Does anyone remember the value that we got? The Y, 21,65 and 12,5. 21,65 and 12,5 newtons. I want to ask a question here. Please only respond if this applies to you. Who is lost? I'm not done. I'm going to do F3. But before I do F3, who is lost? With what I did here so far, I am now only drawing vertical and horizontal forces. 50 newtons was already vertical. That's why we did not resolve. There's no need to resolve that. 35 was horizontal. There's no need to resolve. 60 vertical. There's no need to resolve. We took F1. All right? We took F1 and changed it into vertical and horizontal. Oh, great. Everybody seems to be on the same page with me. Now, F3, up and right. Okay, let me use a different color. Up and right. What was the value? 8,45 and 18,13. 8,45, 8,45 and 18,13. Do you notice what we now have, guys? We only now have vertical and horizontal. That's the aim. The aim is to make sure the only forces you are going to play around with are vertical and horizontal. Now we can go back to what we did yesterday. Convert all the verticals to 1 and convert all the horizontals to 1 and find the resultant. Does that make sense? Let's see now. Is it making sense? Convert all the verticals to 1. Convert all the horizontals to 1. How many verticals do we have? We've got 4 verticals. That must be converted to 1. We have 3 horizontals. That must be converted to 1. Are you okay? Thumbs up, thumbs down with the next line of work to be done. Let's see. Are you okay? Ah, sweet. Guys, I'm clapping for you here. Please make sure you are responding, all right? Because there are some people who are just here. They are afraid to tell me they are not okay. Please don't be afraid. If you are lost, I'll re-explain. That's my job. Awesome. Now, the next step is on you. It's quite a long step because of the number of forces. The next step is on you. Can you now do that for me? Let's combine all the verticals, combine all the horizontals, and find the resultant. This we've done, so you should be able to do this. Convert all the horizontals to 1 horizontal. Convert all the verticals to 1 vertical. Find the resultant by using Pythagoras theorem. All right? And the angle. We are practicing. 5 minutes. 5 good minutes. I'll talk to you after 5 minutes. Make sure you beat the time. Remember to use your plus and minus. All right? Remember to use your plus and minus. It's a vector quantity, so we're talking about direction. I see a lot of us are still busy. Because I want you, guys, once you're done, please send me your answers. Because I want everyone to practice. So I've added 3 more minutes. You are looking for the resultant. So we find the vertical, we find the horizontal. Pythagoras, we get our resultant. And then we find the angle. Quickly, 3 minutes, everybody should be done now. All right. Thank you for all your answers. Let's quickly get this done because I want to round this up as fast as possible. Look, I will take this as positive and negative. Positive and negative. It doesn't matter whether you took opposite directions, but we'll just do that. So I could say up is positive, or you used north as positive. It means my Fy resultant, let's put it that way, Fy resultant, 50 is positive, plus 12,5 is positive, plus 8,45 is positive. But now 60 is the opposite direction, plus negative 60. I hope that makes sense. So we'll put that in a calculator quickly. We don't want to waste time now. What do we have? 50 plus 12,5 plus 8,45 minus 60. What's our answer? 10,95. That's resultant vertical. My answer is positive, right? So I know it is up. All right. Fx resultant. I chose the right side as positive. So what do I have? 18,13 plus 35 plus negative 21,65. We get a calculator. 18,13 plus 35 minus 21,65. And what do we have? My answer is also positive, 31,48, which means it is to the right. Now I am going to quickly draw that to make life easy for me. Up and right. What do I have? 10,95. And what do I have? 31,48 newtons. Guys, I hope my answers are the same with yours so far. What do we do? All right, let me confirm with Layden. I see Layden. Yes, so our answers are the same. Beautiful. Thank you. Thank you. Okay. So see, once you know these things, you don't need to waste time. 5 minutes was good enough. All right. We complete that. We complete that there. That. And then we draw our resultant. Beautiful. Automatically, what do we know? F resultant squared equals to what? Fx squared plus Fy squared. So our F resultant squared, what is Fx, by the way? 31,48 squared plus 10,95 squared. We run to our calculator and get an answer. 31,48 squared plus 10,95 squared. Remember, we need the square root of the answer. 33,33. Great. 33,33 newtons. What about the direction? Check. That's my angle. So, 10. This is Fy, remember? Opposite over adjacent will be 10,95 over 31,48. What is my angle, therefore? So 10,95 divided by 31,48. But remember, it's an angle. So what do we say? Shift 10 of that answer would give us our angle, 19,18 degrees. Guys, Denzel, no, we've already found the square root. Probably you missed that. Keep your eyes on the screen again. All right, it is 31,48 squared plus 10,95 squared. Right, that's our answer. Then we square root. Do you see that? I've already square rooted my answer to give me 33,33. Denzel, are we okay? All right. Guys, please, this is how we find resultant. First, change all inclined to vertical and horizontal. Then what do you do after that? You make sure that you have vertical and horizontal only. Then you combine the verticals, combine the horizontals, find the resultant by using Pythagoras, and you find the angle. You would see the importance of this just now. Are we okay? All right. Guys, are we okay? Let me see quickly. Everybody okay with what we've done? Quite a big class this morning. And I need to make sure everyone is okay, please. I'm looking at everyone giving me thumbs up. I'm trying to check who is not responding. To me is not responding. To me, are you okay? Zoe, are you okay? Okay, Mbali, I saw your response. Dinelle, I didn't see your response. Danilo, I didn't see your response. Brinley, I'm not sure you responded. I might have missed it. Giselle, I'm not sure. Devigan, I'm not sure. All right, I've got a hand up. I don't know if it's a question or you are saying you're okay. Luyanda, Linda Kutle, are we okay? Awesome. Thank you so much, guys. Thank you for following. Beautiful. Beautiful. Now, we are going to talk about something very important here. Forces at equilibrium. So it's a continuation. Force is at equilibrium. All right. We can combine all forces to form a triangle of forces. And that's what we've been doing anyway. Forces are said to be in equilibrium. Take note of that language. If the net or resultant force is equal to 0. When F resultant or F net equals to 0, an object is said to be in equilibrium position. That is, having a velocity that is A, 0. That is, object is stationary. Or B, a velocity that is constant. Object is not changing speed. So when F net is 0, a system is said to be at equilibrium. We are going to use this in our Newton's laws in the next session. Or an object is said to be at equilibrium. An object is said to be at equilibrium. I'm going to draw a quick diagram for you, and then we'll work on something nice quickly. Equilibrium. The net force is equal to what? 0. Just giving you a moment to write. I want to draw a diagram for this thing here. Are we good to go? Anybody still writing? Okay. So this is an example. going to draw that force there, that force there, that force there, that force there. Call this F1, F2, F3, F4. Equilibrium position. We are simply saying the vertical forces are equal in magnitude. So F1 will be equal to what? Negative, okay, let's use magnitude. F1 would be equal in magnitude, all right? But opposite in direction. So here we talk about magnitude. And if it's the direction, then we put a negative there. Again, horizontal forces. Oh, by the way, this then means F1 plus F3 must be equal to 0. All right, Denzel, I'll go back. Horizontal forces are equal in magnitude. Let's just combine this one this time around. And direction. Right? So we're saying F2 is equal to negative F4, such that F2 plus F4 is equal to 0. I'm going to just squeeze an important diagram here. So just find space. This then means that if I have a force like that, and I have a force like this, all right, and have a closed diagram, if I have a force like that and call this F1, okay, I don't want us to mix it, then let me call it F1. What can I call this? Okay, Fx and Fy. And this is F what? Resultant. And that diagram is not new to us. Please, let's write that very fast. I want to do something here. Denzel, I'll go back when I feel everybody's done writing. Because I want us to see an application here now. How will examiners test me on this? Okay, everybody seems to be okay. You can take a screenshot and write the notes later. All right, we're good. Thank you so much, everybody. Now, everybody look at this. Using the concept of equilibrium now to calculate, using the concept of equilibrium to calculate the weight or mass of an object. All right, from grade 10, we're quickly going to talk about something from grade 10. The weight of an object is the gravitational pull. We all know the force of gravity of the earth on the object. All right, so we say W is equal to Fg. And W, capital guys, will be equal to mg, where W is the weight in newtons, Fg is the force of gravity. They are the same, so we're going to be interchanging also in Newton. M is the mass of the object in kilogram, and G is known as the gravitational acceleration. We did this in grade 10 when we're talking about potential energy. All right, and this is 9,8 meters per second squared downwards. We all know this. This is not the first time you are coming across the 9,8. All right, so I'm going to do a question quickly. I'm going to create one, and then you will be able to calculate. I'm just going to create a question. I hope my values are right, because I want you to do some questions on your own, some exam questions. Just a quick one. All right, okay. You should be able to do this. Define the term resultant. Calculate the vertical and horizontal of T2. 3-4 marks there. All right. Magnitude of T1. Oh, okay. That should be doable. Mass of the crate. Ah, easy question. Let's see the next one. Oh, beautiful. Okay, let me do the first one. My dear learners, I'm going to do this one, and then you will take on the second one. In case you are not done writing, just take a screenshot, because we're running out of time. All right, guys. Let's walk through now. Please, one of the errors of learners is your inability to read. We are science learners, so everything you are looking for is numbers. Blah, 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 45. No, we don't do that. All right, so take a look at this question. 11 marks for free. A pulley system is used to keep a crate of mass M, kg, stationary. That word is not new to us now. I gave you the implication of that word stationary. For an object to be stationary, it means that we're talking about an equilibrium system. And when we are talking about an equilibrium, our net force is zero. Now that's my interpretation so far. All right, so we have a diagram. 2.1, everybody should be able to do that now. 2.2, calculate the vertical and horizontal component of T2. My dear learners, please don't let this thing here confuse you. That the force is coming down doesn't mean it's really down. This is it. It is actually here. This 245 is here. Okay, so you are going to do some of the work for me. So we have that. Let me draw that out. We are now answering 2.2. Guys, whatever concept we have done, I'm not going to do it again. You are just going to keep calculating. That's the way we practice. Okay, so we have this. And this is 245 newtons. And the angle here is 30. Please find the vertical component for me and find the horizontal. 4 marks. Let's see. 4 marks. Maximum, I'll give you 4 minutes. So there's no time to waste. You can leave space. You'll draw the diagram later. 4 minutes. All right. I'm seeing answers are coming through. Brinley, you only got me fx. What about the fy? Same with Samantha. Samantha got me fy. There's no fx. I'm just making sure that everyone knows how to get this, guys. This is important. When you get to school now, you are going to be ahead of your class, all right? And you practice more quickly. That's one thing about physics and maths. The quicker you understand, more practice you do, you get it done. All right, so quickly, if I were to do my triangle of forces, I'm going to have that, and I will have that. What will this be? I'll call this T2y and T2x. Which one is opposite? T2y, vertical. So T2y is 245 sine 30, and that is 122,5 newtons. 122,5. All right, and vertical would be T2x. That is next to the angle. So it's 245 cos 30. And I'm picking your answers from the screen. 212,18. 212. Look at this. 1 mark, second. 3rd mark, 4th. 4 marks in the bag. Is that making sense, everybody? Is that making sense? Awesome. All right, so guys, you can see that physics is not difficult once you pay attention and you move systematically. Okay. And please, guys, whenever we're having a class, whenever you're practicing, always write units. Please don't just give your answers. Let's get used to. You can imagine if a learner leaves this like this, because you are now used to practicing without units. Check. Now you have 2/4. That's physics. That's the danger of physics there. Once you miss the unit, you lose those marks. So please, let's take note of that little error. Whether you're practicing, please, unit is a must. All right. So we are done there. 2.2.2. Done. No, that's 2.2.1. Now, 2.2.2. What is the magnitude of T1? Wow, what is this examiner saying? Do you know we have nothing about T1? This examiner must be high or something. How do we do this? Let's draw quickly. I want us to draw. T da. All right. T1 is to the left. Examiner says we should get the value. Okay, but what do we have? We have T2x and we have T2. Okay, T2. This is T2x and what? T2y. Right? What's our T2y? 122,5. What's our T2x? 212,18. By the way, what force do we have here? We have the weight. We spoke about the weight. The weight is always acting down. Look at the force, the diagram we have. And we are told this thing is stationary and it's at equilibrium. Can I take you back to my notes? If it is at equilibrium, what do you notice? F2 should be equal to F4. F1 should be equal to F3. Guys, even if you have two forces here, let's say we have another force here, the addition of the two should be equal to the down one. Vertical forces are equal in magnitude. The total up, please let's put this here. For this vertical, I want you to just put this here. Total up should be equal to total down. For this one, total on the left should be equal to total on the right. Just add that to it for me. Total up, so that you would have at the back of your mind that even if there are three and there's one down, as long as it is in equilibrium, the sum of the three up should be equal to the one down, because the system is at equilibrium. So, do you think we have an answer to this question? What is the magnitude of T1? Do you think we have an answer? The system is at equilibrium. Let's put a dot there. I think we have an answer. The one on the left, total on the left, should be equal to total on the right. So I'll come here and say that T1 therefore should be equal to what? 212,18 newtons. We are done. Check 2 marks. And if you want to show a calculation, we would say, okay, since it's 2 marks, let's do this. Remember, the one on the left and on the right should give you what? 0 at equilibrium. So let me create a new page. I'll say T horizontal, okay, T resultant, horizontal, my R looks like a V. Or instead of using horizontal, we can say T, I want to make it easy for you. X resultant is equal to 0, which means we have what? T1 plus T2y, no, T2x, if you remember that diagram, equals to 0. T1 plus 212,18. T1 therefore is negative, and you know what the negative stands for? It's just the direction, right? 212,18 newtons to the left. But the examiner wanted just the magnitude. Magnitude means we don't need to write direction. All right. I'm just trying to show you the steps. But the system is at equilibrium, and this is how we represent an equilibrium system. Are we okay there, guys? Please talk to me. Did that make sense? Did that make sense? At equilibrium, the forces on the right is equal to the force on the left. The forces upward equal to the force downwards, because the system should be at equilibrium. Ah, great. Simple stuff, ne? All right. Calculate the mass of the crate. Wait. Where is M? Guys, mass is a small m, right? Hold on. W is equal to mg. And this system is at equilibrium. Oh, it means the force pointing upward must be equal to the force pointing downwards. System is at equilibrium. All right. So this is 2.2.2 2.2.3, we're saying the system is at equilibrium. Therefore, Ty resultant must be equal to what? 0. Remember that, right? Just to make it look mathematical, T2y plus W must be equal to 0. What is our T2y? 122,5. You already see where I'm going, right? Plus W equals to 0. So what's W? Negative 122. Remember, the negative only tells us the direction. But what is W? mg. And G is a constant. I see. Can we divide both sides by 9,8? Because G is 9,8. 1225 divided by 9,8. And what is your answer? 12,5. And what is the unit? Kilogram. Physics is the new LO. Did it make sense, my learners? Please let me know. I need a response from everyone. Once we get this done, it's just a matter of applications now. It's a matter of you now applying what we have done. I'll give you just a minute to put down this solution. I don't remember where I got this question paper. I would have told you the year, but I don't remember. If I remember, or I'll search again, I'll tell you where the question paper is, and I'll teach you how to get resources for yourselves. Teach you how to get resources. Quickly, waiting for those of us that are still writing. Okay, there's a hand up there. Atinkosi, Molo.
Morning.
Hi, morning.
So if you substitute the values into the equation W equals mg, do you lose any mark?
If you substitute which value?
122,5 into W without using it the way that you did it. Do you lose any marks along the way?
No, you are not going to lose any mark. If I'm getting you right, you're saying, since I know T2y plus W equals to 0, all right? 122,5, right? But now, if I'm going to substitute wait. You said we should substitute 122,5, right? Because, is this what you're saying? We're going to get a 0 here.
So substituting it into the equation W equals mg.
Oh, all right. No, okay. So here, we bring mg here. Is that what you're saying?
No, sir.
Okay, tell me what you're
So
saying.
we have the equation W equals mg, right?
Yes.
And then we do know that the forces are in equilibrium, so W is equals to 122,5.
Oh, yeah. Yeah, no. So, okay, I get what you're saying. So you just want to do this part. Right?
Yes.
You are okay. It's okay. I'm just using this part here to emphasize what at equilibrium means. Okay?
Yes, sir.
All right. But if you say that quickly, that W equals to mg and 122,5 equals to what? 9,8 m. And m is 12,5 kg. Perfect. Because the examiner would give you a mark for that. Because they know that you saw that the system is at equilibrium.
Thank you, sir.
All right, beautiful. Guys, I hope all of this makes sense to us. So always look out for that word, equilibrium. Let me say this one. I won't do this. This is for you. 9 marks. A pulley system is used to keep a heavy object at rest. That's the language again. Rest means stationary. Stationary means equilibrium. Equilibrium tells you F net is equal to 0. Can you see the language there? 2.1. That everybody should get. 2.2. Draw a vector diagram showing all the forces acting on the object. A vector diagram, guys, let me help you with that one, but you will do the calculation. A vector diagram, I'll use a box. And then I'll draw all my forces. Which force do we have? There's a force going that way, all right? A vector diagram, I was going to look at the difference between vector and free body diagram when I start doing Newton's laws, okay? But let's just answer this. I have another force that way, and I have the weight of the object from the center. Now with a vector diagram, I'll have to show the angles. Okay, so I'm quickly doing that one for us. This is the weight. What is this force? 1440 newtons. What is this force? 1284,95 newtons. I hope everybody's good with that. Now you must show the angles. This angle is 40 degrees and this angle is 55 degrees. And you are done answering that question. 4 marks. Please, there must be arrows and it must be labeled. I will explain the difference between a force diagram and a free body diagram in our next session when we deal with Newton's laws. But that's my answer there. Calculate the weight of the object. Guys, you should be able to do this now. What do? You resolve the 1440 to get vertical and horizontal. You resolve the 1284,95 to get the vertical and horizontal. You will therefore now have how many forces pointing upwards? You're going to have 2 forces pointing upwards. I don't know if that makes sense. Do you understand why it's 2? I'm going to draw them side by side. One left, one right, and the weight. When I do Newton's laws, I'll explain why this is longer. But you would have gotten, just for explanation's sake, let's call this F1. Let's call this F2. So you would have gotten F1x, F1y, then F2y, F2x. Because the system is at equilibrium, what do we know? The total up should be equal to the total down. So W will be equal to what? F1y plus F2y. You need to do that and get the values. Give me a thumbs up if you are okay with my explanation, because we're finishing the class now, but now I have explained what to do. Can you see it's just basically the same? Awesome. Let's see the next question. In the diagram below, the resultant net vector this we did yesterday. Which one is the resultant net vector? And this diagram is actually not new to you, if I'm right. This diagram is not new. Do you want to answer this quickly for me? Let's see something. I'm looking at this question and it looks very tricky. Which one? Somebody says C. Okay, most of you are saying C. F3. Guys, please be careful. Physics will slap you left, right, and center. You guys just saw this diagram. You guys are not thinking. You just saw the diagram, like da-da-da. No, physics will take you up, take you down, pa-pa-pa. I see. People are now taking caution. Check, guys. If you say F3, okay. If I say F1 is my force, F2 is my force, tail to tail here, please don't jump into answering. Reason it out. I will then draw this, right? Using F1 and F2. Do you see your resultant? If F1 and F2 are the forces, that's my resultant. Does that make sense? So F3 cannot be the resultant. This is wrong. All right. Okay. Now, people are saying A. Let's check. So, guys, I hope that makes sense, what I just explained now. So don't jump to say, okay, this diagram, blah, blah, blah. No. Physics, examiners are very clever. Let's see. Could it be F1? Tail to head. Oh, perfect. F1. So basically we have two forces. Tail to head. And then we have another one. No, sorry. Check that. Remember, tail to head. Tail, head, tail. The open end becomes your resultant. So please, let's be very cautious in answering questions. Did that make sense? Why did you all say C? They said C because we've been doing right angle of forces. So you've got to trace the tail and the head. Lovely. Good trick there. I love this examiner already. Okay, look at this one. Define the term resultant vector. Calculate the resultant of the three forces. Okay. Guys, we did this already. Explain why the three forces will not form a closed vector diagram. All right, let me quickly assist you with that one, and then you'll be able to tell me when you are done with the calculation. I'll tell you what a closed diagram is. Okay, I was going to also answer that as we go on. When you say something is a closed vector diagram, it means the resultant force must be equal to 0. That's another language. A closed vector diagram, let me go write it there. Where we just go back to your notes quickly. I am done. Where is it? All right. Just put it there for me. A closed vector diagram means the resultant force is equal to 0. Once you have a resultant force that is equal to 0, it means that we can have this as a closed vector diagram. All right, my dear learners, this is where I am going to drop my pen for the day. You do those questions, and then we would mark in our next session. Fortunately or unfortunately, our next session would be next week during our extra class moment, and that's where we're going to mark and get into Newton's laws, which is a very important. All right, guys, our sessions will be in the afternoons once school reopens. Our extra class for physics, grade 11. All right, this is the schedule. Maths is 6 to 8 p.m. on Tuesdays. Everybody's at home. All right, and physical science on Thursday, 6 to 8 p.m. I'll shed more light on the group. All right, I'll shed more light on the group. Sir, before you leave, may you please go back to the board where you did question 2. All right, let's quickly honor that request. Question 2. Okay, you want this one? Yes to me. Guys, okay, not to keep everyone so long because of our data usage, please share your, if you have questions, you want to get clarity on something, please send a WhatsApp, and then we can attend to your questions and your inquiries right from the office. Denzel, is it this one? Okay, someone wants to take forces at equilibrium. I'm not now sure. Equilibrium. Forces at equilibrium. Okay, someone wants this. All right, Samantha. Okay, to me, is it this one you are referring to? Awesome, guys. You may start leaving the class. We'll talk more on the group. Have a lovely day, guys. I'll send the homework on the group. Okay. Enjoy your day too, Kellen.
Sorry, I didn't get this into the last one.
Which one?
The last question that we did.
I'm not sure of which screen you are looking for. This one?
No, the previous one.
The previous one. This?
Yes, sir. Thank you.
Okay. Goodbye, everybody. Bye, Brinley, Zoe, Mamani. Thank you, Ma'am Mola. Awesome. Sorry?
May God bless you.
Thank you, thank you. Amen to that, Denzel. All right, guys. Have yourselves a lovely day. You may now leave. All right, so you got it. Okay. Bye.